All right, guys. So, major thing about complex numbers. So remember, we had set this up, right? So if I multiply by the square root of -1, I go half of a half. I got a quarter of a turn. Are you with me? So we talked about that last time. And this actually, it's really unfortunate that we don't teach this earlier, because then it would just be normal. But we call it imaginary. We don't teach it to you until you get a pre-calc. So you're like, oh, this is some weird made-up bullshit. No, it's real. It's true. It exists. It's just unfortunate we call them imaginary. Why does this make sense? Because if I do another square root of -1, I end up at -1. And when we checked it, 1 times square root of -1 times square root of -1. So if I do a quarter of a turn, multiply by square root of -1, and then another quarter of a turn, the answer better be freaking -1. That's where it should end up, correct? Just think of it physically. If I turn a quarter of the way, I should end up at -1. What's the square root of -1 times the square root of -1? -1, right? So that works. So what the shit's down here? We haven't talked about that yet. Don't freak out. If that's I, that should be.
The rest of the circle.
Negative I.
Yeah.
Right? And let's check it. So, not surprisingly, I do -1 times I, what do I get?
Negative I.
Holy shit. So every time I take a quarter of a turn, that's I.
Okay.
So now what does this say? This says that -I, quarter of a turn times I. Okay, let's see what the hell this is. Negative square root of 1 times square root of -1. What's square root of -1 times square root of -1? -1 with a negative in front. And what's that? 1. So we do get back. So let me write this a little better. See if this looks familiar to anybody. You have 1, then you have I. So I to the first is I squared 1, 2 is -1. That's the first thing we've ever seen, that when you square it, it comes out negative. Which is a brand new idea to us, which is unfortunate. I wish we would just teach this earlier so it wouldn't be so foreign to us. I cubed, we know that is 1, 2, 3 turns is -I. And I to the fourth, 4 quarter turns, comes back to 1. So then we know what I to the fifth would be.
Negative.
No.
I.
It's I. Because it would be I to the fourth times I, correct? Isn't that 5 i's?
Mm-hmm.
What's I to the fourth? 1 times I. So see how this just keeps repeating. Every fourth power, it's going to come back to 1, isn't it? It's going to go 1, I, -1, -I. 1, I, -I. All right. It's not going to catch on. Top of the charts. So, real quick, can somebody tell me, this is not as important, but you will see problems like this. The most important thing is actually this. That is the most important thing up here, besides just the definition of I, right? But real quick, can somebody figure out what is I to the 81st power?
I can guess.
Every time you get to a fourth, you get back to 1, correct?
Yeah.
So 20.
Good.
20.
So what's the remainder when you divide by 4? What's the remainder?
Is.
Isn't this I to the 80th times I?
Yes.
Every 4, I4 is 1, I8 is 1, I12 is 1, correct?
Mm-hmm.
That's you get to a full circle. So this is just going to be 1.
Oh.
So the shortcut is 4 goes into 81, remainder 1. So I'm I to the first.
Okay.
So if I said, what's I to the 43rd? Okay, 4 goes into 43. I don't care, what's the remainder? 4 goes into 43, what's the remainder? 3. So this is the same thing as I cubed. -I. Why does it work that way? Because then it's just a big circle. It's just going to keep repeating itself. Oh my God, it's just going to keep repeating itself. Oh my God. So I'm just basically saying, all that, take it out and then just see what's the remainder and where do I end up? Because I keep going around the circle every 4, 8, 12, 16. So all that matters is how far past the multiple of 4 did I go? Where did I end up? That idea is important, but is not as important as this. Yes?
Can you explain the shortcut again?
The what now? Sorry?
The shortcut.
Shortcut. 4 goes into 43. I don't care. Remainder 3. 4 goes into 43 10 times. All that matters is the remainder, because I take out all the full turns, and then I have 1, 2, 3 turns left. Negative I. Okay, maybe. So every multiple of 4, I just come back to 1. Every multiple of 4, I just come back to 1. So just take out all the freaking multiples of 4, and then just see how many steps past that did you go. What's the remainder?
Those are the, I don't know if this is a question, but those are the only points, like you can't like stop.
Oh,
Do you
dude,
know what I'm-
dude. All right, I'm not.
Sorry if I.
We will go here. A really good question is, can I turn by this much?
Yeah.
Yes, you can. Okay. We're not going to do a lot with that visually, but we will actually work directly with that in a minute, believe it or not. I is imaginary number, is what its name is, unfortunately, right? A complex number. Every number you've ever seen is actually a complex number. A complex number looks like this. 5 plus 2i. Does it have a real part? What's the real part of that? 5. What's the imaginary part of that? 2i. There you go. So watch this. This basically answers your exact question. If I see this as the I-axis, right? I, 2i, 3i, and I see this as the real axis. 1, 2, 3, 4, 5. Can you plot 5 plus 2i? 5 plus 2i. Real part, imaginary part. So it's almost like a point, but now I have a real axis and an imaginary axis. So yes, anytime I stop partway through, see, anything on this axis is purely real. Anything on this axis is purely imaginary. So anything halfway in between is going to be a mixture of real and imaginary. Okay. I like it. So right now I know you're like, okay, what am I going to do with this shit, Jeff? What do I have to worry about? Okay. The most basic thing we're going to have to do is going to be so kick-ass awesome. Can you guys add to complex numbers? Watch this. Just go with what your gut says. What is 5 plus 2i plus 4 minus 7i? What's your gut tell you? That
Yes, because they have the same exponent.
Sure. More importantly, they have like terms, correct? What do you get from the numbers? 5 plus 4, 9. 2 i's minus 7 i's.
-5.
Okay, you didn't expect it to be that easy.
No.
No.
But I is just like x. Can you tell me what the square root of negative 1 is? No, so we give it a variable, not a variable name. We actually give it the variable I. It's not a variable, it's sort of like pi. Pi doesn't mean anything. It means specifically 3.141592, blah, blah, blah. Right? I means specifically square root of negative 1, but nobody in here can tell me what's the square root of negative 1. We just gave it a symbol because it's a freaking little dude, right? So I just combine all my real stuff and I combine all my imaginary stuff and I'm done. Now, the more interesting question is multiplying. The first step is old shit. So let's multiply these two things together. You do exactly what you hoped you would do. Well, what you hoped you'd do is to not do this, but given that you have to do this.
Distribute.
Yeah, 5 times 4,
20.
20. 5 times negative 7i.
5.
5 times negative 7i. Negative 35i.
Oh, okay.
Not a big deal. 2i times 4. 8i. 2i times negative 7i. 2i times
Negative 14i squared.
All right, so let me put this up here.
That's for unison.
So I have 20 minus 17i, is that cool? No, Jeff,
Yeah.
it's not cool.
Oh.
27i. I thought there was an 18. Minus 14i squared, I'm not done.
Can't you
I just
factor that?
combine like terms. So far it just looks like the same shit with just an x instead of an I, right? But I is not like x. I has a value, and you guys know what I squared is. So isn't there part of this I can still do?
Yes.
Yeah, can't you,
What is I squared?
1?
No. The whole idea of it is, it's the first thing we've ever seen that when I square it, it comes out negative. So then I get 20 minus 27i plus 14, so I get 34 minus 27i. Crazy shit.
Oh, okay.
Okay. Maybe. So up to this step is just as if it was an x. But then it's not an x, it's a number, so I can do more shit to it. And this is a complex number because it has a real part plus an imaginary part. So you should always be able to get any problem like this down to a plus bi. Every number you've ever seen before today had b0, correct? Have you ever seen the number 11 before? Wouldn't that be 11 plus 0i? Are you with me? So every number you've ever seen is a complex number where b was 0. Yes?
Where did you get 34?
20 and
20 plus 14.
Oh, okay.
Yeah.
So you can't do the 20 and the 27i because it's multiplication. Those aren't like terms.
It's subtraction, and they're not like terms.
Subtraction, they're not
Yeah.
like terms. But
Exactly.
with multiplication, you.
Yeah, if I was
Yeah.
multiplying those, it would be 540. Yeah.
Why does the I squared become -1? I don't understand.
We did that before. What is I again? What's the definition of I? What does I mean? Good. So what is I times I? It's going to be square root of -1 times square root of -1, which is -1. So we know that I squared is -1. I circled that bad boy and said that's the most important thing that was up there. Doing like I to the 87th power, who cares? It's good. You have to know how to do it. This is what's important. This is stupid important because we've never seen anything we can square and get a negative number, ever. Until now. And you're all like, I could have gone my whole life, Jeff, and never seen it. Well, no, because you're here. Too bad. Yeah, there's not a lot more with complex numbers besides this. You're not going to have to do too much with them. If you're worried about graphing shit and whatever, we're not going to graph a lot of shit. The graphs I made are just explanatory. If you go further in mathematics, you do a lot more with complex numbers, for damn sure. I'm sorry, who had a hand up? You good? Okay. Yeah.
So I'm still confused on like the I-81 for the.
Oh, yeah. So, again, every fourth power is going to come back to 1 because I complete the circle. So I to the 8th is 1. I to the 9th is one more I on top of that. So, of course, it's I, right? 4 goes into 8 twice with 1 left over.
Okay.
So the thing to know is I to the 0 is 1 because anything to the 0 is 1. I to the first is I, because anything to the first power is itself. I squared, we investigated and got this, yes. I cubed, anybody remember what that is? Negative I.
-1. Or negative I, sorry.
I to the 4th gets me back to, and I start over again. So what is I to the 800th power?
1.
1. Because 4 goes to 800, so I did 200 revolutions. I got back to 1, correct? What is I to the 8, so that's 1, 803rd power? Well, I did 200 revolutions, and then an extra 3, so I ended up at negative I. So the remainder tells you where you are in this list. So if I were you, I would make this list and have it sitting next to me as I did my homework. Crazy shit. Can't do that on a test, though. Nah. Okay, maybe.
So 1 for chapter 2.
I should the negative first be negative I.
Oh, okay. You're kind of getting ahead of me a little bit. I'm sorry. Did I erase? what do you guys think about, how do I do, remind me, how do you do this? 3 divided by square root of 5. Just remind me. Multiply by
Multiply
Square.
by
Square root of
the
5.
square root.
So you get 3 rad 5 over 5. Okay. Isn't I just the square root of a number? Isn't that what I is? That's what I do be. I get a lot of neat grammar when I teach imagine. What is I? All right, sorry. Why is I? I'll do you one better. Why is more? So if I had 4 over I, it's the same problem. I can multiply by I,
Oh, okay.
right? Then what do I get? On the top, I'll do the top. Okay.
4i over I.
No, I
Oh,
times
no,
I,
I squared.
which is?
Negative 1.
So I get negative 4i. So your question, if it was 1 divided by I, it does become negative I, because when you rationalize it, what you get? 11. So I is a radical. Everything radicals do, it will do also. So, with that in mind, how do you do this shit? Yeah. In this case, math people, right? We're really smart. We go, well, it's conjugate, but there's complex, so we call it the complex conjugate. So it's the same stupid idea. You multiply by 3 plus I. I'll do the top. Okay. What do you guys get on the bottom? What do you get when you FOIL it?
Minus I plus I. Oh,
3 times 3.
9.
There we go. Minus 3i plus 3i. The middle terms cancel. They will always cancel when I do a conjugate, because that's why we do a conjugate.
And then negative I.
Negative I times I is minus I squared. What's I squared?
Negative 1.
Negative.
9 minus negative 1 is?
10.
10, and you can reduce this, but who cares? It's the exact same idea, bless you, as radical expressions, because that's all I is a radical term. It's a weird radical term, but it's still just a radical term.
If we were doing that on like a quiz or something, would you want us to go farther into like?
Yeah, you should, yeah. You
parentheses
should do 6
3?
plus 2i over 5, because you divide everything by 2, right?
Oh, I meant
Reduce it.
like, would you do 4 and then parentheses 3 plus?
Oh, no,
5?
no. Real quick thing about this. When the instructions say simplify, can anyone tell me what that means? Yes.
Just like reduce it to its smallest form, not necessarily.
For a
solve
fraction,
it.
but I mean in general. If I
Oh.
just say simplify, what am I asking you to do?
Maybe it's solve.
Not solve.
Simplify means carry out the operations. So if I said simplify 6 times 8, you would look around like, really? And you would tell me what? 6 times 8. 48. Okay. Took longer than I wanted. Okay. So when I say simplify, that means carry out the operations. When I say factor, that means undo multiplication, right? Simplify and factor, 2 separate things. They actually are opposites of each other. Factor means break shit apart, simplify means put shit together, right? So if the instructions say simplify, you shouldn't be factoring. If the instructions say factoring, you most of the time shouldn't be simplifying. Okay. All right. All right. So that's complex numbers. Why do we just study complex numbers? Well, number 1, because they exist. Number 2, because they could be answers to questions. So for example, do you guys remember, what to do in, let's do this first. Yeah, I like this. You can do it, Jeff. You do it, buddy. There you go. How do I solve that equation?
Well, first you add 12. You do the exponent. No.
You have to factor it.
If that wasn't there,
Then you would add 12.
then I would add 12 divided by 4, right? Why do I do that? Because all my x shit is in one term, correct?
Oh, yeah.
Or if I had like another x somewhere, I could put all my x shit in one term. Can I do that? Can I combine all my x shit into one term? No. So I need a different method. Anytime there's a higher power than 1 on your variable, you should try to get everything equal to 0. Why 0? Why does this have to be 0 here for this to work? Give me two numbers that multiply to be 8.
1 and 8.
4 times 2, 1 times 8. Keep going. I'll help you out. Negative 1 times negative 8. Give me another 2.
1 times 8.
I already did that. Negative 4 times negative 2. Give me another 2. You can do it. You can do it. I said number. I didn't say whole number. 16 times a half. Yes? Give me another 2.
32 times a quarter.
32 times 1/4. 800 times 1/100th. Isn't that 8? How long could it keep going? Frickin' ever. Now, give me two numbers that multiply to be 0. Give it to me.
Infinity times 0.
Careful, no. I appreciate that. Just give me one.
1
So,
times 0.
huh?
1 times 0.
1 times 0. Holy shit, give me another one.
5 times 0.
5 times 0. So generalize. Can you generalize what the answer looks like?
Yes.
And I know that's what you're trying to do, but it would be any number times 0, correct? So when two numbers multiply by 0, we know something. One of them has to be 0. If two numbers multiply by 8, does either one of them have to be shit? Could either one of them be anything it wants to be as long as the other dude makes it 8, correct? Too many unknowns. So if this number is not 0 and you have a higher power than 1, you got to make it 0. Because if I break this down, I have number times number is 0. And we know one of them's got to be 0. So then we can get answers. If it was 8, I don't know, shit. Could be any damn thing. So how do I factor this?
X plus 6 and then x minus 2.
And then I can get my answers because I know that either this number is 0, yes? Or this number is 0.
Don't you have the plus or minus with it? In the
No.
answer? The
So we
plus
had x
and
equals
Negative 6.
negative
or
6,
positive 2.
x equals 2.
just 2, yeah.
So that's how to solve a quadratic.
It's 2 answers.
Yeah, equation. Then you solve the x plus 6.
Yeah. You're thinking maybe with squares. We'll get
I
there.
think I am, yeah.
Yeah. So this should be old news. Right? Factor can help you solve. So I take a single equation with the second degree and I make it 2 equations with first degrees because that's the good trade-off. I can solve each of those. Those are simple. This is gross, so I trade it off. I make more problems, but each problem is easy. Okay, maybe? Remember the thing that was said the other day in the video? What's the highest degree of the problem? What's the highest degree of the problem?
2.
2. How many answers again?
2.
2. What about this? Can you factor that?
Yes.
Yes.
Tell me how.
Um,
And think about it.
X plus
X
3, x minus
3 times negative 3 is
3. Negative.
not positive. Try again. So what about x plus 3 times x plus 3? What's wrong with that?
6x.
I get him 6x in the middle, correct? Same problem as x minus 3, correct? All right, so let me show you 2 ways to do this. I can subtract 9, and I can do that because I've got x in a single term. How do I undo the square?
square root.
Anybody remember what I have to put when I put a square root?
Parenthesis 1.
This is your plus and minus that you're talking about, right? If you take a square root, you got to get plus or minus. Because what do I square to get 25? What do I square to get 25? Or negative 5, right? So if you take a square root, plus or minus, because both of them work. Now somebody help me out. I'll do this side. There you go. Oh boy. All right.
So it's
What is the square root of 9 and the square root of negative 1? Hi. Before we knew complex numbers existed, that was impossible to solve. That's basically the same kind of problem you had up there in the video we saw, right? Now, of course, you know where this is going. This is a quadratic equation. What's funny is quadratic means 4, correct? But this is a second degree. So why is it quadratic? Because real quick, just go with me for a second.
Doesn't it make this?
Real quick, yeah. What's the area of that? You can do it.
You just add those two together, so it's.
No, that would be like half a perimeter. How do you get area?
Oh, area,
Multiply. So would it be x squared minus 2x minus 6x plus 8, right? So the people that did this, they realized that this kind of thing comes from the area of a square. Square's got 4 sides, so that's why they call it quadratic. Because it almost comes. Okay, you didn't have to know all that, but part of me is like quadratic means 4, and that's a 2. What the shit? But you know, that's why. So you know where this is going. What if I had a quadratic problem, but I have something I can't factor?
You use the quadratic.
Quadratic, that's right.
Wait, what?
Quadratic
Quadratic.
equation, quadratic formula, right?
The opposite of.
Now, if I had more time, in the interest of time, I'm not going to prove the quadratic formula, which is unfortunate. But you guys remember it.
I probably just need to remember it again.
I'll get it started. Negative b
Plus or minus.
plus or minus
The square root of b squared minus 4 times a times c all over 2 times a.
Oh, and
Right.
then you plug in,
Yep.
so,
Now again, I'm probably going to prove this to you next time because I'm not going to be able to not. Because I really hate just going, this is what it is. Has anybody ever seen where the hell this comes from, or have you ever just been told, do this? Have you seen where it comes from?
yeah.
You have to use something called completing the square.
Oh, yeah.
By the way, on Canvas, I think it's the last module, it's got prerequisite stuff. One of them is solving quadratic equations. So I go over factoring, I go over quadratic formula, I go over completing the square, and I go over this method. Those are all on that handout.
I don't remember which numbers are A, B, and C though. Is it the middle
It's
is?
just.
Oh.
It's just left to right.
ax
Oh, it's just
squared
left to right?
plus
Yeah.
bx plus c. So if you solve this, you get this.
Okay.
You know, like, I'll take your word for it, man. Let's see. Oh, this is awesome. I got some time. Too bad for you guys. Just to remind you, chapter 1, chapter 2, it's basically all of math before pre-calc. And that's why they are so packed with stuff, because there's a lot of math before pre-calc. Once we get to chapter 3, things are going to slow down a bit. Y'all with? So we're not going to keep this kind of like pace the whole semester. With that said, what's the absolute value for it?
4.
Why?
Because it takes 4 times.
Oh, good, yeah.
4 times.
So what's the absolute value of negative 4?
4.
4.
So both of them are 4, because if I ask you, Jeff, if I ask you how far away from 0 is 4, you'd say it's 4 steps away. How far away from 0 is negative 4?
It's also 4 steps.
Still 4 steps. You wouldn't say that you're a negative 6 feet away from me, even if I turn around, because that would mean this, you know, inside of me, like, Quaid, you know, that's not good. So I would never say negative distance. Doesn't make any sense, right? Absolute value is based on distance from 0. That's why the answer is always non-negative. What's the only number the answer is not positive?
0.
Good, because 0 is not positive. It's not negative either. But, here we go. Here we go. What is the absolute value of x?
Oops. It could be anything.
X.
Can't be x, because what could x be?
Anything.
X could be negative. So if you thought this is true and x is negative 5,
Well, then is it plus or minus x?
not quite, because I only get one answer for an absolute value question, right?
Oh.
So here's our first taste of what's called a piecewise function.
Gosh. Wait,
Not-
P.
Not pennywise function.
Y.
Nothing's floating. If x is positive, can somebody tell me what does the absolute value do if x is not negative? If the number I put in is not negative, does the absolute value do anything?
No.
Absolute value 4 is 4. Absolute value 0 is 0. Absolute value 7 is 7. Doesn't do shit. So if the input is positive, it stays the same. What happens if the input is negative? So-
It becomes positive.
Changes the sign. How do I mathematically change the sign of something? Not from Cancer to
Multiply by negative
Libra.
one.
Yes?
Multiply by negative.
Yes. So if it's negative, the absolute value is actually this, and your brain balks at this. Is this true for anybody? Doesn't your brain go, what the shit? Absolute value is supposed to be positive. That is positive. What's x here? Isn't x negative? And what's negative times negative? Positive. So let's try it. Let's try it. Absolute value negative 7. Let's use the definition. That's a negative number, so it's going to be negative that number. What's negative negative 7? 7. I like it. Now what this leads to is a way to deal with absolute value equations. So let me just do one thing real quick and I'll let us out of here. If I had this equation, I'll do two things actually. Haha, I always lie. What are the answers?
X
Six.
is 4.
Yeah, either x is 4
4 or negative 4.
or x is negative 4, right?
Oh.
So what about, here's the last problem we'll do. What about this problem?
Ew.
What is 2x minus 5? If I knew what x was, what would 2x minus 5 become? It's a weird question, I know. But if x was 3,
But
2x minus 5 becomes a number, correct? You guys with me? So it is a number. The absolute value of what is 11? Either this could be 11, correct? If 2x minus 5 was 11, wouldn't the absolute value of 2x minus 5 be 11?
yeah.
What else could 2x minus 5 be? What else do you take the absolute value of to get 11? So the thing inside could be negative 11. You get two cases because there are two things that can take the absolute value of to get a number, correct? So of course I get two cases. Then you just solve each case. Add 5, 16, divide by 2, you get 8. Add 5, you get negative 6, divide by 2, you get negative 3. You just have to solve each one now. So absolute value equations will have two cases. Either the inside is already positive or the inside is the negative of this. Because both of them make this true. Does that make sense?
Yeah.
Yes?
So I did 2x minus 5 and negative 2x plus 5.
Oh, sure, that'll work too. I like doing this because it kind of leads into the next inequality stuff a little better, yeah. All right, guys, that's plenty. Of course. Yes.